So below, uh, like the title of the talk is Peace and Facilitating around Python's performance. Uh, it's a motivator for this talk in that I've been around in Miami for years, and for many years I've been core developer 5i, like Python chip compiler with a lot of forms of performance. And at the day we have tried R2, but like Python as fast as possible. And and then I realized that talking to people around conferences and etc. There are the misconceptions about Python performance, what makes Python slow, even slow, what they can do. And I purpose the idea to try to uh, like organize some game in them and try to understand what is the tool of this of the stuff. And I would like to start with what I call it, like misconceptions that a lot of people think about Python performance and that I don't think they're true. And the first one is that Python is not slow. Here we talk about many people that tell you that Python is fast enough for them what they need to do. And that's pretty defined because they use a library which are fast the other corollary is like Python is just a dual language. All the important stuff is quickly like NumPy or nowadays you run your GPU, so you don't care that Python power is slow because Python is a dual language which combines everything together. And it's kind of true from some point of view. Like there are a lot of programs on which Python is fast enough, and that's like you can use it nowadays. You shouldn't profit, then be happy. There are a lot of programs where Python is not fast enough already nowadays, and that's why usually people open Cody. For many years I worked as a freelancer and like kind of performance expert. So companies order me to try to optimize their code, and that's obvious that if that other people try to make the code faster, they see that it's not fast enough. So that's already. But even more than that, there is a whole series of programs which you cannot just use Python to do because like some of the robots on the lantern are not good enough. So yes, Python is fast enough for the keep the delivery nowadays, but there are a whole bunch of possibilities that we are not. We are just missing, and it would be nice to be able to use Python for more. And the second related near is that okay, you have your Python program, you find it slow, just need to find the slow part and rewrite it even in C or C++, and that becomes magically faster. And nowadays, actually, everybody seems to write things in Rust instead of C or C++, but it's kind of the same. And that's actually, for example, what happened like a numerical computation. You don't write for rules that doing a computation of your arrays. You use NumPy to spice the C, and everything is fast, and we are really there is something like the core idea is that this works because of the Pareto principle. I didn't feel like to write the slide. I asked ChatGPT to write it for me. Pareto principle is also the 80-20 rule. Let's say what is it? It's basically a principle which says that in any piece of code, like 80% of the runtime is spent into 20% of a program. Maybe sometimes or sometimes 10. Anyway, like a big part of the performance is spent in a small part. So you can just optimize that one and be happy. And for the break, and write it in C and call it a day. And yes, it works up to a certain extent. The other problem is that there is this other law called the House of Law, which like here that we did it in the fly along with the great law. It's very easy to visualize. Imagine that you start with the program in which you have this 80-20 rule. So you have the linear function inside the loop which occupies all of your runtime, like 80% of your runtime. And then you optimize it. And now you see it's very, very tiny. And so I optimized the overall runtime of one program. But then the rest of the program, now it's bottleneck. There is only a certain amount of division that you will here, and now I need to find a way to optimize the rest. And so there are a certain amount of governing fluids that after race, we need to find other ways of making our birth faster. Another thing that people claim is that Python it's slow because it's in third. And the thing that's just come next is that, someone on Twitter announced that there is a new project that is LLVM or already understands technology and to make Python fast, and then it will be the magical fast. There is a bit of truth in it, but most of the Python slowness doesn't come from the Jezebel. It comes from the semantics. So for example, imagine a very easy piece of code. You have like some point, and you have X and Y fields, and you want to play it. And if you write this code in C or C++, Rust, any low-level language, at the CE level, what you need to do is, one load instruction to get the value X of memory, more multiplication, and then store. 3 assembly instruction, and you're done. And if you do it in Python, so imagine that they is some root like data class, which you will end the point, and etc. How many operations do I need to do? Who knows what happens when I go to this though? But what happens is, first of all, I need to find the type of P. And then I need to see whether there is a standard get attribute in it or defining the clocks. And then I get X. And then I go to find the type. And then how do I know how to multiply it? Well, there is a random move, or maybe it's an error move, depending on the phase of the move. And then there is some object somewhere. And I need to unbox it, like get the actual value from this piece of memory which has this somewhere, unbox it to multiply. Box the result, which means I need to malloc a new state. By the fact that this was my 2 seconds explanation, this is I don't even understand what I say, should get a sense of how much work Python is to in order to do a SQL operation. And this is not something that the interpreter alone, a compiler around to fix, because it's not about integrated versus compiler, it's about like how data is stored to memory. But you can say there is like a way of an easy fix, because nowadays you like study types. Who likes study types? Everybody. No, not everybody, but N people. So yeah, so I can write a function and say that yes, I don't have to do all this nonsense of get attribute as well, but because I know that X and Y are integers and my functions as an integer, so I can just combine it fast. And imagine that you have a compiler for Python and you want to combine add a function, and you can just do this, what is short for C++, load, but add or multiply, store, and we are ready. Do we agree? You? No? No, because study types are local, but they basically are bad. They don't guarantee anything. So, for example, if I have this product, totally passes the type checker because I'm explicitly it to your design of code, but then it means that if I want to be combined, I cannot combine these functions using shortcuts. I need to preserve the original Python semantic, which was of the accept that I was talking about. And okay, you can say that, but maybe like you can make special cases and etc. And or I can just declare that typing YAR is not allowed in a program. So I'm not allowed to ignore type annotations, and then my compiler can finally emit fast code. But no, because it Python look crazy nonsense like this. You have a class which defines the underpad method, and then this bunch of works because I know that my compiler called this method, and then at some point in the program I delete method. That is perfect for valid but the Python. And so my goal, if it was to be compliant, I need to take care of it. And again, I mean that they cannot be fast. So I'm trying to see this from the point of view of the compiler. So I need to look by this suite of code, these two functions. And I would like to learn some varieties about what is the shape of the object, which is the size of the object, is very chaotic, because it could change around time. Uh, so the obvious solution is use a JIT compiler. JIT compiler is a special form of compilation which compiles stuff just in time, at on time, and this means that he can know better what is the actual shape of data and what is the actual shape of classes, and indeed the JIT compiler can solve many of the problems that I talked about so far. PyPy is an example of compiler. It can behave very well in these cases. And CPython, as an experimental JIT compiler nowadays, it's getting better, and it can make this code fast. So, problem solved. One problem is solved, but then they introduce another one. And I have this trade-off triple, in which you can have in a language dynamicity, you can have speed, we can have simple implementation. Pick two. We can add all of that. So what CPython has done so far as the Latin language and simple implementation, and it was like, let's say, score. What's getting now with compiler is you can get faster, at the cost of a very confusing notation, because JIT compilers are a hard piece of software, usually the very expensive to develop it, but also to understand how they work. And the problem is that having a complex implementation will make it very hard to reason about performance. Because in Python so far, yes, it's dynamic, we have implementation, and we can predict that our code will be fast or slow. The JIT compiler, and I know by experience, it will do very, very hard, because maybe you have some piece of code which will be work good enough, and then you modify it online an unrelated file, and then JIT compiler to fuse it, can no longer understand your role, and FGB standard time stored. And then you end up in this equation, which I call optimization chasing, in which you start with this old language, let's say Python 3G11, and you optimize the fast path. Like you see at most Python programs behaving this way, so the JIT compiler optimized for this particular way of writing programs. And everybody is either neither far or faster, and everybody is. But then, in a couple of years, people always got to rely on this performance, and they expect this kind of special performance from the tester there. And then, here's my code still fast at some point, and they're in a very strange situation, because, I mean, if what they say before, when you change something, and everything if you have to 2 times over, 10 times over, whatever, and it's very good because the compiler know that they need to make code slow because you change this nice code, but they don't tell it. It becomes very hard to debug such stuff. And so maybe it's possible to write circuit tools like this, but by my experience, it practice very hard. My experience was in PyPy, and I was a developer of PyPy. I know very well how the JIT work, and that I spent hours for days to understand why this particular code written by customers were suddenly slow. And I figured that, I mean, with CPython, we kind of get addicted to that direction. And it makes very hard to reason about your code. It takes really good thing for if anybody wants to freelancing for Python performance, that as the general rule fast. And so this is like very, very fixed version of what, like concrete progress. And but why we have all these code that we're talking about? I think that I like to think about compilers. Like from a point of view of the compiler, you want you say piece of Python code, and you want to meet fast.free. What do you use? And if you see this kind of code, and you are a human, it's very obvious what it does. Because I'm working on Py, there is a global constant to the n, and the value is my combined I. Either function which takes an array of floats and the constant, then does SAPI and returns a float, obviously. From a human point of view, it's very obvious. But if you're a compiler, you cannot assume any of that. No Py, they mean something else. Because they stuff with sysdot modules or portals group is not by definitions. And you could check at any point in time. Type validation taken live is already already. So we have to emit code for like and be the conservative and we can move fast. So from some of the view, all the time is the fighter, which will be like I want to say like a fighter, but it's also what makes Python slow, but also at the same time. And now I'm giving a series of example of why it's not hard. Right? So you have class by put in it, and I'm get like I have a function. We take a point, and I know it here because I don't trust type annotation, right? But here I'm checking at runtime that it is actually a point, and then it brings min a, and what is it? Because I don't have a main here. Does it work? That this can work or not? Well, I can tell that the arbitrary attributes to classes from outside, and then this works. So at the end, I cannot assume much about the shape of my objects and my classes. Like, what about this code? If this one, it is possibly a code. But like, just to show you how great each capit, I have this class which can have or not have the hello method, and I will target to know that. And if I want to compile this code, what do? I mean, I need to go this route past. I am a class student, which is a native name, and a network study, and this Ninja student is studying something. And then I have a beginner, which is not a student, and is still studying his part below the Kai. And then I have this, I create okay, this branch is student, not person. I create an instance on student, and I ask stay. So what can I do here to make it different than what you expect? I can, for example, change the class of an object at runtime until something that most people don't know it's possible, but it's actually for it. Python is totally validated. It's such a well-defined semantics. It makes it impossible to reason about the code. It makes it possible to optimize it. So limit. If you change, I'm sure that if CPython today, if Lucas commits something to CPython to make this illegal, there will be tons of Python code which support it, because maybe some crazy library, somebody is actually using it for some reason. I worked over this. And also better. Let's continue with create established can happen. Now I have class person and there's a class student which is completely unrelated. No inheritance. There is nothing. And I'm creating a person, and I'm calling inventory in name and age, and I assert that it's actually a person. What can go wrong? How it was? Does anybody know how I can this code cannot work? I'm creating a person and assuming that it's actually a person.
Accessing the persons. Or accessing the attributes. You can write something other.
Okay, what?
When you are accessing their attributes name and age, you can modify the.
Okay, that opinion of T is that's it. Worse that. Now, what we can do for the states? So I can have the data new, which should have something else. So you instantiate the person and you get a skewer, which I end again. There is code around what it is, and okay, okay. We understand that maybe constants are not constant because someone at some point could check them. But I have foo, I have bar, and I code it. We actually got the block, and at some point later I called it. Are we sure that this goes on the safe bet here? No. Of course not, because I said in the put there this line. That so for instance, something which could affect shares that stuff like. So you can take a function, and though the function that the global dictionary is looking up is something different. And and now four is strange because it truly looks there, but then just doesn't point there, but some people did different. And if you think it is too crazy, there is code it can be taught in real life. And it's code that a lot of people is using, which is exactly what it is. It's rebind rows. And this is from EDB++, which is the debugger, which it's like EDB but better with colors and completion and etc. And well, it does this, so well, they need to develop handles it. And if you want to chase this guy and say, okay, get nonsense, well, we should write better code. That person was me many years ago. He broke this particular code. And I claim it was a good thing to do because Python allowed me, but still, like, you should do bad idea. It's very hard to optimize Python. And so the compiler has a very long time. But even from the point of view of the human, there are stuff that you need to think about. And trade-off that it would be better not to have to do, but you have. And here I'm talking about the section of the rep. There is something which I call like Python to Python translation overhead, which is I start with a Python code, which is like certain speed. We already saw that it cannot be super fast. Let's say that it's fast enough for our purpose. But I'd like to refactor it and truly improve the maintainability of my code and make it better. And the problem is that in Python, every layer of abstraction has a cost in terms of performance. So here, I have this algorithm which have a list of points, we should double, and then repeat some functions. And then I want to prove it, and I put the code for considering this function into the real micro function. And this is more winnable because I can reason about this function by itself, etc. But this is already slower than 4. Because an iteration, I needed to look up the FN and to stop arguments, call it all these as operands. And maybe I want to head points as nice as possible so that I get a better record and other nice stuff. But again, the competitive is lower because then every time I need to pay cost for accessing that with H and that with Y. And you remember the slide before, like pay.text was to look up where these methods and try to understand stuff. It's very hard to optimize. So we have this trade-off. We would like to make our code better. We would like to make our code more maintainable. But every step of this direction has a cost in terms of performance. And I mean, abstraction is due because it's actually what makes our code complex practice dual. Because we see the demo abstraction, we want black boxes that you can just call and don't think about that. But there's this trade-off which is not super good. And that thing that you can do, it's, well, we talked about it already. We can write stuff in C and make it faster. But let's go back a bit here. Earlier we were talking about the JIT combiner. And it's partly a solution. So, normal Python interpreter has a hard time to make this code fast because of all the analytics that we talked about. So, all lookup, all attribute access, they need to be happen at runtime, and they tend as to do the logs all bound all the time. But the JIT compiler can assume things, and maybe it can represent our list of points as a flat array in memory, and have a special assembler code which is super fast and they're heavy, and this code is kind of fast enough, okay? But then I want to rewrite stuff to C for speed. And then Fn maybe suddenly no longer by a function, but it's a function within the C. And it's indeed the function itself, it is faster. But the JIT compiler cannot see through it. So what was like the code which is all invited was fast, now it becomes slower because every time we go Fn, which is written in C, you had to like create Python notation that make it exist just to pass them to C, so that C code can delete the Python address, the detection value, and create a Python address to return, and no need a Python, and there is a lot of work for nothing. And this is kind of unsolvable problem. As far as I know, I don't see solutions into it, and every time you remove stuff from Python to C, you make some case faster, but you made the library very much harder, and that's trade-off with no easy solution. And finally, there is what I find in the root. Like it's something that it's big problem in Python for Python learners. Nobody talks about, although almost nobody talks about, because what do they know? Memory management. Like on modern CDOs, like let's say combination, like doing arithmetic of values and this kind of stuff, we can do move like billions of operation per second, and then be then fast. But we need to take this data from somewhere, and there is like the memory hierarchy where you have like multiple layers of memory even with different names. Some are big and slow, some are the smaller and fast, and your data could be in one of these cache memory like L1, L2, L2, L3, and they are super fast. Or can be in RAM, and it's very, very slow. And a way of that it could perform is make sure that the data that you need is always in the cache, so that the CPU can quickly get it to do computation and then routine. If your data happens to be in the main memory, RAM, then this queue has to wait until the data is available to do the actual computation. So like from this point of view, whenever you have the cache easiest, which is like try to load something, it's not in the cache and need to wait for RAM, it's a disaster for person who to do it. And when I say disaster, this animation shows different speeds of various, I can use ChatGPT to wait. I hope it's fast, but in the actual speed are reasonable. So in the amount of time that I go to RAM to do one memory access, you see how many I can do in L1, L2, or L3, and so accessing L1 cache like 2 CPU cycles. It's very, very fast, and L2 and L3 are like some cycles, but RAM is like thousands, and the CPU is doing nothing because you are already remembering it. And so what you need to do is to write stuff in such a way that your database always in the cache or ready available for the CPU. The problem is that Python is not designed for that. And what usually happens is that the CPU holds and assumes that only data that you want are closing memory. So if you are accessing this address, and then it preloads the next addresses in the memory, and they do the input it into the cache. So if you are accessing just one after the other, it's very good. But in Python, like mainly if you are a person with the age and the list of persons, in memory this represents MITs. So if you have a list of persons and instances, and at index 0, you have the instance which has dictionary, which contains a string and then mainly it. And imagine that you want to iterate over that you start and the CPU loads things are ready to it. So now 0 and 1 are in cache. But then I need to go and follow this pointer to load the person with this. So I need to put another. Is the data which I need is somewhere else, cache releases. And then I need to follow this, it's cache releases again. And then I go back here. 1 was in the cache before. But now it's no longer because I charged my cache to load and date, so I need to reload it again. That is something which happens in real life, and it's impossible to solve unless you completely change the way data is stored in memory, which it can be easily because you need to respect all the conservative of my language because of vulnerability that peak is showed So it's kind of unsolvable problem. I feel that it will be pragmatic for the this Skinner package are friendly, then there is not much we can put on. I mean, we are almost at the end of the presentation. How much time we left? Okay. I would say that the set to build the final penalty super fast. And the wind is not what people wanted to the conclusion that people wanted to hear, but he can be fast enough, yes. But if they want to be very fast and reach the next level of performance, I either would direct compatibility with some of the dynamicity or we get to find it. So as the other said, no, I guess it would be nice if now the like is announcement in which I say, oh yes, that's a super incredible project. I so well to grow that. That's not true. I have some ideas how to move forward, but there is nothing spread of me to be honest. One way of moving forward and like really reach the level of performance, the next level of performance is that we need to cycle up to the side step. We need to tweak the language semantics so that some of the strange coordinator which I talked about earlier become impossible or more easy to manage from the compiler point of view. But we don't want to constrain it too much because what we like about FireDub is that it's the dynamic mechanism which is kind of stuff. And you can add a lot of very useful stuff which relies on beginners, like meta classes, decorators, standard methods. Maybe you don't write it, but all the libraries that you're using in life, they rely on these features to get the nice GPA that you're using. So we can remove that. But we need to find a way to fit enough dynamicity so that it's still nice, useful, but remove what you don't need. And we need to a way so that we can build abstraction, a couple of abstractions without statistic penalties. And we did a new text system, which is oriented to performance, because the current text system that we're using is, well, it's a hub on top of existing languages. Like Python is completely dynamic, and then we try to find rules. It's mostly a linter. It's not a type checker, and it's not useful at all for performance. And finally, we need a way to remove this package barrier, and so that if we mix Python and C code or Rust code together, the optimizer can see through the code and write the best assembly code possible. And in general, we need to do autistic, but like staying what I call Pythonic. I want the ceiling of the Zulu language to be more as Python as possible, so that it's still like it. So I added indeed this like super work in progress RD project, which is called Spy for start Python, which is try to experiment with these ideas to create let's say a Python compiler that is not really idle because, as I say, I'm trying to remove a bit of a private type. It doesn't stay there. Okay. And so yeah, so maybe next conference how will be to present this. Actually, I didn't like as a result by a pediatric conference. And we'll see how it goes. If you want to follow it, like there is this presentation which I made at FICO US some months ago, which explained the ideas, and they're also about to be beta rebel. And speaking of code quality, everybody knows that it's very good to write good documentation, and you should write it. That I don't put my own phases because the Yuk at the read takes less at the current documentation of spot. Here.
I hope you like because it was really peaceful. I spotted one sauce in your career, but I flew the exam as software reviews it.
Could you do that? What? Could you do that? Yeah.
Okay, I was regarding the static functions. Because you showed on what we use static type skill arguments is much faster, yeah. As for instance, for you store information in the classes, in order to pass it to the function, you first need to get that feeds as attributes from the class. So we're looking here, so in order to make it faster, it needs to get rid of those classes completely, yeah.
Well, not completely, but like, I suppose you're talking about
So I'll go first to IKEA. Yeah. And some like before. Yeah. But this one like this before, yeah.
so like the problem of this is that anything can change at any time. So even if I claim that list of points, that maybe list could be something theirs, and they'll take some other class such as X and Y, and they need to prepare to handle. And the other problem of classes in Python is that because of the semantics of the language, I cannot write a pass point in which X and Y are next to each other in memory. I need to go through these arrows that I showed in the last slide. And we need a different semantic, but we need a way so that the terminal is able to pack FTD there and then so get me faster. Like I'm not sure. I think I'm not answering your question, but
Yeah, so for instance, in that case, that use something which without like it or two parties, so or use class something like that.
something like what? Like to know, or I don't know. Should I use this or brutally super fast? Instead of this better plus. Like, but then when you want to access the X, you still need to find it somewhere, and you don't know what is it, and you need to return on time. Okay, let's continue later because I want to answer you, but I don't want to answer you.
I also have a question regarding is CPU cache, because you compare to RAM to the CPU cache, so as I checked, even the low-level programming languages cannot explicitly allow you to use that CPU. The choices in Rust, it used that as a macro to this, yeah. Or for instance, in C++, team together specially prepared compiling instructions and layer, but you cannot use it directly because you want backups.
You cannot say I won't use the cache. This is something that is controlled by CPU, but you can lay out your data in memory in a way that is faster. And that's like if you search for like database design, that's actually what they do. Like they have all techniques to put your data in memory and your address so that it's cache friendly and you can be sure to always hit the cache. But in Python, it's just impossible to do because you have no control on the data area.
And when I use that design, it's like abstract. The first you makes it accessible to the cache, yeah.
Do what?
Like for instance, when I use that design level languages, yeah, it would be like stored by cache, but like lock explicitly by the abstraction, and yes, it's actually very okay. Wait, no.
I don't know.
So this Spy project is it's like I have a field of Python. Is it built differently, or what exactly is it?
So Spy is completely branded new implementation. It's it is not based on Python at all. Like it's written in Python right now, but it will be written in Spy eventually. Imagine that you want to write a compiler for a new language with like in compiler for C. Well, you write it, and you write a parser, and you write IR code, and then you have a backend which means several code. So this is basically what Spy does, but it does for language which is very similar to Python. That's what this.
Okay, so it will not work if you feed it the Python code, right?
Yes, it's not being 100% compatible with Python is not the goal of Spy, because what I said earlier, like I think it's impossible to have the level of permanent MI without reference first.
But if you would create a superset on the language, like for example, I explain,
Generally speak, I don't know how to put that. Okay,
if you do, please help because something is not the preface or the module. Yeah, that's exactly.
no, the claim if you don't. Like the claim, oh, we are Python superset, they are not. Like FP, very like be compatible with Python's mean that you can create jumbles, write it to module and work. That's not true. And every language that which with this end up with like here because they get 80% of the language and then they can do the other 10%. Okay.
Step back. Two. Big fix.